Okay guys, we continue solving our task, and the next task will be the following. It's called difference of number of distance value on diagonal. So we are given some grid M and N, and we have to find the matrix answer of size M and N. The cell of this answer is calculated by looking at the diagonal values of the cell. Let left RC be the number of distant value on the diagonal to the left and above the cell, not including the cell RC itself. All right. Left, right, below be the number of distant values on the diagonal to the right and below the cell, not including the cell grid RC itself. So then the answer left and right would be a difference between them. A matrix diagonal is a diagonal line of cells starting from some cell in either the topmost row or leftmost column and going to the bottom right direction until the end of the matrix is reached. So, for example, in the below diagonal, in the below diagram, the diagonal is highlighted using the cell with indices 2, 3, colored gray. Red colored cells are left and above the cell. Blue colored are right and below the cell. All right. So return the matrix answer. So for example, so let's try to understand this question. So we have we have a grid like this. So we have 1, 2, 3, then we have 3, 1, 5, then 3, 2, 1, right? And output of this grid would be 1, 1, 0, 1, 0, 1, and 0, 1, 1. Okay, and y. So then we have calculation. So left above is 0. Right below elements is 1 and 1. Okay. So we have 1 and 1 equal to 1. Right below. Left above and right below. So right below we have 1 and 1, and left below is 0. So 0 minus 1 would be 1. Okay, then we have 0, 1. We have again 0. And here we have 5. So it's number of unique maybe, yeah? Okay, 1. Then we have 1 and 2. It would be 0, 0. Okay. Then we have 1 and 1. It would be 0 and 2. 1. And so on. Yeah, interesting one. Okay, so here, for example, we have 0. And for this one, we have 7, 13, so we have 3. Okay, let's write once again. Okay, we have a grid. Okay, and this grid, it would be at looking at diagonals. The left above by the number of distance value on this diagonal to the left, and about the cell, not including this cell, right below by the number of distance value on the diagonal to the right, and below, not including this. All right, okay, I understand. Okay, so what can we do? We actually can calculate all distant values by diagonals and then calculate. So I believe that we can create some kind of diagonal distinct values. So for example, we have 0, 0. So what kind of diagonals we have? Then we have 1, 1 and 2, 2. It's first diagonal. Then we have diagonal 0, 1, 1, 2, and 0, 2. So by this diagonal, we have the following arrays. So by first, it would be always 0. Then, yeah, it would be 0. But by diagonal, yeah, we can maybe iterate 2 times. Okay, let's check discussion. Okay. So what kind of grid we can have? 50. So actually for every we can maybe do m over n by m over n. So if they are equals, then it will be n squared multiplied by n squared, so n in fourth power, n in fourth power. So we have 50 in fourth power, 50 multiplied by 50, 50 and by 50. So we have, yeah, 5 by 5. Yeah, so I think we can do this. Just go by diagonals and check. So for example, for this one, we start calculating, we check all diagonals until the end, and collect numbers at the left and right. And yeah, and doing some kind of DFS. Okay, so let's try. So we have our result that should be an array of grid lengths. Then we should just have two loops of grid lengths I++. Here we have another loop with j, grid 0, j++. And here for result I and j, we actually call the function calc, where we send our grids and send I and j. So the point where we start, and then we return our result. And now we have to implement this calc function. So this calc function will receive this grid. We'll receive I and j. First, it will collect in a set integer left percent. Yeah, and here it would be go while yeah, it would be go above. Yeah, it will go above. So while I is greater or equal to 0, and is greater or equal to 0, and yeah, -1, because we should not take these elements as well. And column as well, I think. So j -1 should be also greater or equal to 0. Then we add to left, add grid I -1, j -1. Here yeah, so let's so we have two manipulations here, right? So let's, yeah, so iterate left. Okay, so let's do like li I and int lj j. Here it will be li lj. Yeah, it would start like this, I think. Let's start like this. And li lj li minus minus lj minus minus. All right, so here we collect left, and also we have to collect right. So we implement right, so it would be ri rj, but now we would do plus, and here ri should be less than grid length, and rj should be less than grid length. All right, and now we take ri, rj, ri plus plus, rj plus plus, and we have right. And after this, we just return left size minus right size, and all this we cover with absolute value. And let's check. Okay, so we see here is null, so it's null because, yeah, in a grid we see null cannot strike here. So yeah, let's up.